Welcome to Lecture 5 of DT101, Prototype, Making Ideas Tangible. By this point in the process, you've done your empathy work, you've defined a sharp problem statement, and you've run an ideation session that generated a lot of possibilities. Now comes the question every team asks, which of these ideas is actually right? The answer is, you don't know yet. And the fastest way to find out is to build something, not to think harder, not to debate longer, but to make the idea physical enough that real users can react to it. That's what prototyping is. Here's where we are in the course. Lectures 1 through 4 covered the thinking side, understanding users, framing the problem, generating ideas. Lecture 5 is where we cross into making. And Lecture 6, test, follows directly from today, because a prototype without a test is just craft. The two are inseparable. The first thing to understand about prototypes is what they're actually for. They're not deliverables. They're not evidence that you're making progress. They're learning tools. When you build something, even something rough, it forces an idea to become concrete. Vague concepts that seemed compelling in an ideation session suddenly reveal their gaps when you try to draw them. You discover questions you didn't know you had. That's valuable. But here's the critical part, a prototype only has value when real users interact with it. A prototype that sits on your desk or gets demoed only to your own team has taught you almost nothing. The whole point is to put it in front of someone who wasn't in the room when you designed it, and watch what happens. And critically, keep it rough. Polished prototypes backfire. When something looks finished, users hesitate to criticize it. They don't want to be rude about something that clearly took effort. You actually get less honest feedback from a more polished prototype. Roughness is a feature, not a flaw. There's a mindset shift that happens when you get good at prototyping, and it's worth naming explicitly. You stop thinking of failure as something to avoid and start thinking of it as information to collect. Fail early to succeed sooner means something precise. A failed prototype, one where users got confused, or rejected the concept entirely, tells you something invaluable before you've committed serious time and money. The other mindset shift is about attachment. Teams almost always fall in love with their prototypes. You put time and thought into something and it's easy to start defending it rather than testing it. The antidote is to make multiple prototypes simultaneously. We'll come back to that. One of the most important decisions in prototyping is how much fidelity you need. Fidelity means how closely the prototype resembles the finished product, in look, feel, and function. Low fidelity, paper sketches, cardboard models, quick drawings. These take minutes to make and minutes to change. Medium fidelity, wireframes, foam models, clickable mock-ups. These take hours and reveal structural issues. High fidelity, polished user interfaces, working code. These take days or weeks and are appropriate for testing fine details. The rule: stay at the lowest fidelity that can still answer the question you're testing. Because every hour you spend polishing a prototype is an hour you could have spent learning from a test. You only go up in fidelity when lower fidelity genuinely can't tell you what you need to know. Paper prototyping is the most underestimated tool in design thinking. Teams dismiss it because it looks childish. Those teams are wrong. The method is simple: draw every screen or state of your product on a separate sheet of paper. Use sticky notes for buttons, overlays, and pop-ups. When you test it with a user, have a facilitator physically swap sheets as the user navigates, tapping on paper buttons, following paper flows. It sounds silly until you watch a user point at a navigation button, realize they have no idea where it goes, and say, "I'd expect this to take me to," oh, that's not what happened. You've just found a critical navigation problem in under an hour, at zero cost. That same issue, found in a coded product 6 weeks later, costs a week of development to fix. When your idea is more of a service or an experience than a discrete product, paper screens won't capture what you need to test. Storyboarding is the better tool. A storyboard sketches the full user journey in 6 to 8 frames, the context before they encounter your product, the key moments of interaction, and what happens afterward. The before and after is important. Often the most powerful design opportunities aren't inside the product at all, they're in the moments that lead to it, or the moments that follow. Storyboards also force you to show emotion. When you draw the user in each frame, you have to decide, are they anxious here? Relieved? Confused? Making that visible often reveals assumptions your team was making quietly. For service design especially, there's a technique that goes even further than storyboarding: bodystorming. You assign team members to roles, some play the user, some play the system, some represent environmental factors like a busy queue or a broken printer, and you physically walk through a scenario in real time. The reason it works is that the body knows things diagrams don't. When you're physically standing in the user role and the system role doesn't respond for 10 seconds, you feel the frustration in a way you can't feel it on paper. Assumptions that looked reasonable in a flowchart turn out to create real problems when they're acted out live. No physical artifact required. Just people, space, and a scenario. Eventually there are questions that paper can't answer, questions about interaction patterns, tap target sizes, the hierarchy of a complex screen, or how a multi-step flow feels when you're actually clicking through it. That's when you move to digital wireframes. Don't go digital because it feels more professional. Go digital because paper has genuinely hit its limit. And when you do go digital, resist the urge to add color, choose fonts, or polish the visual design. The moment you add polish, users start reacting to the aesthetics instead of the interaction, and you've lost the ability to test the thing you actually wanted to test. Tools like Figma and Balsamic have sketch or rough modes for exactly this reason. A good prototype has 4 qualities, and if any one of them is missing, the prototype will either mislead you or teach you nothing. Testable: a real user who wasn't involved in creating it can interact with it meaningfully and try to accomplish a task. If users can't engage with it without you explaining how it works, it's not testable. Focused: it's built to test one specific assumption, maybe 2. Not everything at once. What is the one thing you need to learn? Disposable: you genuinely need to be willing to throw it away. If you'd feel uncomfortable discarding it after a test session, you've already overinvested and your testing will be biased. Minimal: it's the simplest version that can still answer the question. Not the simplest version possible, the simplest version that's sufficient. Here's one of the most practical and counterintuitive recommendations in design thinking: build more than one prototype simultaneously. Not sequentially, simultaneously. When a team builds one prototype, they anchor on it. But when you build 2 or 3 versions and test them side by side, users give sharper, more specific feedback when they can compare, and the best solution often combines elements across versions in ways nobody predicted. The psychological benefit is just as real as the design benefit. It's hard to fall in love with a specific solution when you're working on 3 at the same time. For mistakes that show up consistently, and they're all worth calling out by name. Too polished, too soon: you've invested so much in the prototype that it's now hard to change, emotionally and practically. The cost of learning has gone up just when learning is most valuable. Testing the wrong assumption: you built a beautiful prototype to test visual design when the real risk was whether users understood the core concept at all. Always ask, what is the most important thing we don't know yet? Build for that. Attachment: you've fallen in love with a specific solution and you're now using the test to confirm it rather than challenge it. You'll find what you're looking for. Which is a problem. An used prototype: the team builds it, has one internal review, and moves forward without ever putting it in front of a real user. A prototype that doesn't get tested hasn't taught you anything. It's just spent time. 3 things to take away from today. First, prototypes are learning tools, not deliverables. The purpose of building is to answer a specific question, and you should be able to name that question before you pick up the pen. Second, start low fidelity and increase only when the lower fidelity genuinely can't answer what you need to know. Every hour spent on unnecessary polish is an hour borrowed from learning. Third, build multiple prototypes in parallel rather than one polished version. It prevents attachment, produces better user feedback, and almost always leads to a better final design. In Lecture 6, Test, we focus on what happens after you've built the prototype. How do you run a test session, stay neutral as a facilitator, capture feedback usefully, and decide what to do with what you learn? 3 questions to reflect on before the next lecture. First, what is the real cost of making your first prototype too polished? Think beyond the obvious. There's a financial cost, but there are also less visible costs in team dynamics, feedback quality, and your own ability to learn. What are they? Second, imagine you're redesigning the check-in experience at a hospital. Would you choose paper prototyping, storyboarding, or role-play bodystorming, and why? There's no single right answer, but the reasoning matters. And third, how do you know when your prototype is testing the wrong assumption, and what would you do to catch that risk early?